Okay, so in this one, yep, if I plug in what x equals down here for x, okay, now that bottom equation is going to say 3 times 3 minus 2y, okay, plus 6y equals 6. And then I'm going to distribute. So I get 9 minus 6y plus 6y equals 6. And then when I go to combine like terms, do you see that these are going to cancel each other out? And you're left with 9 equals 6. What value of y would ever make 9 equal to 6? Nothing, okay? This is impossible because this came out to two different numbers that are not equal to each other. So this is a no solution, okay? So if you come down to two numbers that are not equal to each other, it's no solution because there's no value of y that would make this sentence true, okay? What would this look like on a graph, by the way? When have we had no solution?
When x equals a number, or x equals 3?
Not quite. Okay, I want to make sure you don't think that necessarily. Like, it's okay to have x equals something, okay? Sometimes that's going to happen and it's going to be perfectly fine. What I want to think about is on a graph, if I were to graph these two things, what would they look like that would make it be no solution? Clarence?
They don't intersect.
Okay, and these are both linear, right? These are both going to be lines. So what kind of lines don't intersect?
Parallel.
These would be parallel lines, yeah. If you graphed them, they would be parallel. Did anyone finish the second one? I know I didn't give you a ton of time, but. Okay. Make sure you have the second one at least written down. We'll do it together because it has some scary fractions in it. Okay. So I have what y equals, 6 minus x over 6. I'm going to plug that in place of y down here. So now this equation down on the bottom says x over 3 plus 2 times parentheses 6 minus x over 6 equals 12. And I know you're scared of those fractions, but I'm going to stick with them for a second. So I'm going to distribute the 2. So I get x over 3. 2 times 6 is 12. And then when I do this, that's really going to give me 2x over 6. See how I did that? 2 times x over 6. But what is 2 over 6 reduced to? 1/3. So this 2 over 6 really reduces to 1 over 3. So what that really says now is x over 3 plus 12 minus x over 3 equals 12. So what happens here again? Oh, I think go ahead. Did I lose you somewhere?
Why? So you completely eliminate the 2y then? You plug in.
I eliminated the y. The 2 is still there.
Oh.
Okay, so I plug this in place of the y. Okay? So the 2 is still there, and I just put the parentheses in place of the y. What happens with my x's again? They cancel out again, but this time, look at what I'm left with. I'm left with 12 equals 12. Is that a true statement? And that's a true statement no matter what my value of x is, right? That's always true. So this is what we call infinitely many solutions. Okay, infinitely many solutions. Now, normally when we solve a system, we're finding the place where they intersect, right? So almost every system we've solved has been like two lines that cross or two somethings that cross, and you find the intersection point, okay? Sometimes there's one intersection, sometimes there's two, but it's two things that cross. We said that if there's no solution, either they're parallel, and we said parallel here because these were lines, but you've had other things that don't cross, right? Like a parabola, well, not a parabola, a line and a hyperbola, you could make those not cross. But how do you make something cross infinitely many times? Yeah, they're right on top of each other. Good. So if I were to graph these two things, I would find that one line would look like this, and then the other line would come along. It's actually the exact same line in disguise. Okay? And that's when you end up with infinitely many solutions. Okay? All right, one last word to throw at you. Consistent versus inconsistent. Okay? And I'll be honest, I don't care about these words a whole lot, but they do show up on your homework, so I want to make sure you know. Consistent is a system that has a solution. Which, what do you think that means inconsistent means? Yep. So if there's a solution, it's consistent. If there's no solution, we call it inconsistent. Okay, I promise the second method is going to go a lot faster than this. Okay, this was 3 pages of notes, the other one's only 1. So we're in the home stretch here. Okay, give you a minute to jot those down. Take like a 1-minute brain break if you need to stand up, stretch, chat with a neighbor, something like that. Just take a minute to pull yourselves together and prepare for me to talk at you some more.